Okay, let's look at 13.9. Banker services, considering a project that's going to have an initial cost of $10 million as expected life of 3 years. 30% probability of good. If that happens, we're going to have $9 million cash flow for 3 years. 40% probability of average, and the cash flows will be $4.5 million for 3 years. And there's a 30% probability of bad conditions, and the cash flow be minus 1.5 per year. If it chooses, it can close down the project in any year and sell related good for 90%. The related assets, we're going to use straight line. Okay, and we have a 12% weighted average cost of capital. Okay, find the project's expected NPV with and without the abandonment option. Okay, let's look at the without. Okay, here we're going to set up our tree here. Here's our 10 million that the project cost. Negative, and we have a negative 10 here at top project 0. Okay, here we have our 30% excellent, average, and poor conditions or bad. Okay, if we have good conditions, we're going to have a $9 million cash flow for 3 years. There's 4.5 and negative 1.5 for bad conditions. Okay, so we're going to just find the NPV of just this branch right here. Okay, so we just say the NPV, and our rate is the 12%. Okay, here's our values right here, and we're going to have to add our cash flow at time period 0 at the end. All right, like we've been doing. Okay, so this NPV is 11.62. Okay, now we want to just multiply it by the probability to find our product here, and that we're going to use that to find our expected NPV. Okay, so we do the same thing for this. We find the NPV of just this branch, and we still use our same weighted average cost of capital. These are our values, and here our cash flow time 1, 2, and 3, and here's our cash flow at year 0. You can see it right here in the formula bar. All right, then we would also multiply this times 40% to get our 0.32. You don't have to worry about standard deviation coefficient variation for this problem. Just disregard this. Okay, and then do the same thing for this last branch here. Okay, now you want to sum these up. The expected NPV, what it equals is the NPV of this branch times its probability plus the NPV of this branch times its probability plus the NPV of this branch times its probability. And we find an expected NPV of a negative 2.7 million. Okay? Now let's look at the can abandon option, and we'll do that in the next video.